All right, so in this video, we're going to look at working with some trig limits. And you are going to encounter from time to time two special trig limits. And the first one that you'll see, and it's be very helpful to use when working with trig limits, is the limit as x approaches 0 of sine of x divided by x. Now, if I go to evaluate this, the first step is to always put in or use direct substitution. So if I put in 0, sine of 0 is 0, and x, um, put in 0 for x, I get 0 over 0, indeterminate form. And so we're going to use, because we don't have other tools at the moment other than the table and the graph. So I'm going to fill in the table. I already have the table typed in here on the right-hand side. And so I'm going to put in values as I approach 0 from both sides. So and I'll fill in the table here. And so we see that according to the table, as I approach 0 from the left, my y values are approaching 1. As I approach 0 from the right, my y values approaches 1. So this limit as x approaches 0 of sine of x divided by x is equal to 1. And we can see that same thing here graphically. If I zoom in, the graph as I approach 0 from either side is approaching 1. Okay, a second very common limit that you'd see from time to time is the limit as x approaches 0 of 1 minus cosine of x divided by x. And if I did direct substitution, I knew that my denominator was 0. My numerator, 1 minus cosine of 0, would be 1 minus 1. That's also 0, so indeterminate form. Now, using the tabular approach, and I've already filled in this table, and I have it over here on the right-hand side with Desmos, and even graphically, if we zoom in, we can see that as your x values approach 0 from the left, the y values are getting closer and closer to 0. As I approach 0 from the right-hand side, the y values are getting closer and closer to 0. So the value of this limit is 0. Now we're going to use those two special trig limits that we need to have committed to memory, along with some properties of limits to solve some of these limits involving trig. Looking at this problem, I see that I have sine of x in the numerator and an x in the denominator. So the special trig limit that's probably, or that is going to be used, is going to be that sine of x over x limit. What I'm going to do is I'm going to change my variable to like theta, just so that way we can see how I'm going to approach this problem as I start working through it. So it'd be sine of theta over theta here. So I just changed all the letters in this original trig limit to a different variable is all I did. And we know that this limit is equal to 1 from what we just did earlier in the video. So first thing I'm going to do is I'm going to use my properties of limits. I'm going to pull this 2 off. We'll pull it outside of the limit. And I'm going to rewrite it. I'm going to rewrite it as 1/2 times the limit as x approaches 0 for sine of 3x over x. And now this limit is close to what I need, but it's not exact. See, in order to apply the special trig limit, what is inside of the sine function has to be in the denominator, and it also has to be what is approaching 0. So I have to get that match. Well, I have 3 times x inside of sine, and it's not going to be very easy for me to rewrite the sine of a triple angle. So what I'm going to do is I'm going to adjust, and I'm going to try to put a 3 down here in my denominator. In doing so, I would have to multiply my denominator by 3 and multiply my numerator by 3 at the same time and rewrite the problem. So we'd have 1/2 times the limit as x approaches 0 of 3 times sine of 3x divided by 3 times x. And now what we're going to do is we're going to take this 3 and we're going to put it outside of the limit. And so we'd have 3/2 times the limit as x approaches 0 for sine of 3x divided by 3x. Now we are very close to being able to apply the limit because we have what is inside of sine is in the denominator. So I have 3x inside of sine. I am dividing by 3x. The only part that we also have to show now is that our original limit, what was inside of sine and in the denominator, had to be approaching 0. Well, I have as x approaches 0 instead of 3x approaches 0. What we need to do here is make a note. So we'd have to note that as x approaches 0, 3 times x is approaching 0. And so since that's the case, we could do that. We could rewrite this limit as 3/2 times the limit of sine of 3x divided by 3x as 3x approaches 0. Now that we have that, we could apply our special trig limit and say this is 3/2 times 1, which is 3/2. Now let's look at another one. So the limit as x approaches 0 of 1 minus cosine of 2x divided by x. Now, our special trig limit that resembles this is the limit as theta approaches 0. That looks like a 0, but it's theta. Of 1 minus cosine of x divided by x is equal to 0. Make that look a little better. Now, I didn't do it on the first example, but it's always, always, always my first move to do direct substitution, just to show that indeterminate form. I'd have 0 my denominator, and I would get 1 minus 1, 0 my numerator. And so this is why we're continuing forward with this approach. So I need to try to rewrite this problem to resemble what we have here. Now notice we have 2x inside of cosine. And in fact, these shouldn't be x's. Those should match. Those should be thetas. So what's inside of cosine has to be in my quotient. So if I have 2x inside of cosine here, I need to have 2x in my denominator. So my first move would be to create that 2 times x in my denominator, which means I'm going to have to multiply the numerator and the denominator by 2. Now, I'm not going to distribute that 2. What I'm going to do is I'm going to take this 2 and I'm going to pull it outside of the limit there. So it'll be 2 times the limit as x approaches 0 of 1 minus cosine of 2x divided by 2x. Now, we are very close to being able to apply our special trig limit. We have what's inside a cosine in the denominator. We just need it to be approaching 0. So I'm going to make a statement that as x approaches 0, 2 times x is also approaching 0, which means that we could rewrite that limit as the limit as 2x approaches 0 of 1 minus cosine of 2x divided by 2x. And we know, according to our special trig limits, that that is equal to 0. So the way I'm going to approach this problem that has tangent involved is just like I would any other one. I'm always going to start off by doing direct substitution. So I get 0 my numerator and tangent of 0 is 0. So I have the indeterminate form. Now, from here, because we don't have a special trig limit defined yet for tangent, we need to rewrite it in terms of sine and cosine. So I rewrite this as the limit as x approaches 0 of 5x divided by tangent of 5x as sine of 5 times x divided by cosine of 5 times x. Then I'm going to do skip, change, flip to rewrite. So it'd be the limit as x approaches 0 of 5x times cosine of 5x divided by sine of 5 times x. Now, this, to a lot of people, we're going to say, well, how did this make anything any better? Because I still, if I did direct substitution and I checked and I put 0 in, I still have 0 over 0. I haven't helped myself out much. However, if you look at what you have, I now see sine of 5x, and I see 5x on the other side. Now, I know that our special trig limit was sine of the angle divided by the angle. However, I can still use this. And so I'm going to use the property of limits, and I'm going to create the product of two separate functions. So I'm going to keep the 5x with the sine and multiply that to the limit as x approaches 0 of cosine of 5 times x. Now, this first limit here, even though it's upside down, our special trig limit that we have is the limit as an angle is approaching 0 of sine of that angle divided by that angle is equal to 1. Well, if I reciprocate that fraction, so if I flip it, what I would also have to do is I would have to flip what it equaled to make 1. Well, the reciprocal of 1 is still 1. So all I need to do is show that I can apply this limit, and so I have the angle inside of the sine, and it's 5x is on the other side. I just need to make this statement here, and then I could apply that limit. So as x approaches 0, 5x also approaches 0. And so we could write it as the limit as 5x approaches 0 of 5x divided by sine of 5x times limit as x approaches 0 of cosine of 5x. And now we're ready to do direct substitution. So I'm going to work my way to the right. The first limit is 1. The second limit, cosine of 0 is 1. So we have 1 times 1, which is 1. Last example here. So limit as x approaches 0 of sine squared of 2x divided by 3x squared. I do direct substitution to see what I get. Sine of 0 is 0. 0 squared is 0. Divided by 0. So I'm at this stage. Indeterminate form. Great. All right, so I have to use some properties of limits here. Now, what I'm going to do is I have a couple of things going on. I have multiplication of a constant here with the 3, and I have two functions being squared. So before I worry about the trig part, I'm going to use some properties of limits to rewrite. So first thing I'm going to do is I'm going to pull out a 1/3. So I have 1/3 times the limit as x approaches 0 of sine squared of 2x divided by x squared. Now, since I can see the two functions being squared, I can use the property of limit. It says we can pull the power onto the outside.
And that takes us to here.
So now our focus is on the very inside, where I can see I'm getting ready to use that sine limit. So I need what's inside of sine to be the quotient and to also be what is approaching 0. So we're trying to use this limit as an angle is approaching 0 of sine of that angle divided by that angle. That's the limit we want to use. So in order to do that, I'm going to have to do some algebraic adjustments. So I have 1/3 times the limit as x approaches 0 of sine of 2x divided by x, and then that's being squared. So my algebraic adjustment is I need to create the times 2x in the denominator, which means I also have to multiply the sine of 2x in the numerator and then go to work from here. Now I can also at the same time make that statement that I'm going to have to do, which means that as x approaches 0, 2x is also approaching 0. So my next line is going to be 1/3 times. Now I'm going to leave myself some space to see why here in just a minute. The limit is 2x approaches 0. And all of this stuff is being squared. Now I needed the 2x in the denominator, and I needed a sine of 2x in the numerator. I'm going to take this 2 that was supposed to be multiplying it to the sine and use the property of limits that says I could pull it outside of the limit. It didn't go all the way outside of the parentheses, it just went outside of the limit here. So I have 2 times that limit. Now we're ready to use that property, or the special trig limit, which says I could rewrite that limit as the angle approaches 0 of sine of that angle divided by that angle as equaling 1. So I have 1/3 times 2 times 1 being squared, which gives me an answer of 4/3.